My name is Stephen Kosler. I work for Youngstrom. I'm a business development manager for our Advex global team, which includes SBS, HBS, and with me is Tony Wiedekamp, the plant manager at the Hallador Power Miram Generating Station.
Miram Station, it's a 2-unit station, 540 megawatts each. Construction was started in '79. First unit came online in 1981. Riley Stoker boiler, Siemens Westinghouse turbines, equipped with an SCR, FGD, electrostatic precipitators, SBS system. The SCR was installed in 2003. So I started in August of 2001, started in operations, changed into maintenance, took over as a plant manager.
So now you run the whole thing?
Yes.
All right.
Try to.
Yeah.
But yeah.
What kind of coal do you burn here?
High sulfur coal. Yep.
Illinois Basin high
Yes.
sulfur coal.
Mm-hmm.
And so you were here when the SCRs were installed. So
Yeah, I can remember the installation.
traditionally, when an SCR is installed on a high sulfur coal unit, you get quite a bit of ABS formation. We kind of know this now.
Yeah.
So the SCR oxidizes SO2 to SO3,
Yep.
and then you have a pretty nice plume coming out of the stack.
Yeah, you could definitely tell blue plume, before we put the SBS system in, especially in the season. Ozone season,
Yeah.
you could see a blue plume, and it settled pretty big area around here.
Tell me when you installed the SBS system, where the injection location is. And
We installed the SBS system in 2012, 2013. The lances go in prior to the SCR. 20 lances on each unit. Been in service for obviously 10 plus years, and minimal issues with the overall system.
so we've touched a little bit on acid gas issues prior to SBS common in the industry, particularly high sulfur fuel, and then you have your SCRs on top of that, generating more SO3. So you guys struggled a bit with air heater fouling, corrosion, buildup on the air heaters. This kind of forced you guys to raise your gas outlet temperature pretty hot, and that was a pretty common control philosophy for high sulfur units, high SO3 unit, in order to reduce or mitigate fouling of the air heaters.
Yeah, so with the SBS system, the fouling is a lot less on the air heaters, which you have to blow them a lot less on outage times. Doesn't take as much, and with being able to lower your gas out temperatures helps, a lot also.
We've quantified that with you guys, and going from 350 degrees down to 250 degrees was about a 2% heat rate improvement on these units. Prior to SBS, every outage you'd have Boilermakers patching the ID fans. Were you doing maintenance at that point in your career?
I can remember that, and yes, and there was quite a few holes to patch during that time frame. So
and that's gone away once the acid gas has gone away. Pretty significant financial improvement for the system.
Yeah.
The injection skid has an MCC in it, and it also has a PLC in it for controls, local controls there in the skid. The PLC is tied into the DCS system here at Miram in the control room. Each unit has their own injection manifolds, and then, as you said earlier, 20 lances on each unit. Since originally installed, you've backed off the number of lances now running.
Yeah, we typically run 16, and that's mainly just because of the ductwork configuration.
How's your plume looked ever since installing SBS? We drove in, it was a nice clear day.
Yeah, zero plume since SBS has been installed. We don't see it at all.
Does the SBS reagent have any impact on your ability to capture the fly ash or ESP performance, or even the ability to market and sell the fly ash?
Does not impact the fly ash, and we do sell fly ash. Same with gypsum.
SO3 actually conditions the fly ash, and so it actually aids in ESP performance. And so there's oftentimes a concern that by removing the SO3, then it changes the properties of the fly ash. Has it impacted your ability or your ESP performance?
No. We have opacity monitors. That's what we monitor, how we monitor. And, we stay in compliance and no issues there.
Air heater washing.
We use our own system. We have wash skids and bringing in the third party, typically high volume, low pressure, and we have to treat that water because it's metal cleaning water, which makes it difficult. We'd have to process about 1 million gallons. We're using our system, going through the air heater wash, it's about 150,000 gallons. A lot less water used on an air heater wash.
Okay, great.
Yeah.
Air heater DP or soot blowing frequencies or pressures.
We just do the recommended soot blowing pressure and frequencies.
Can you recall the last time you had to come down on a forced outage due to air heater DP?
We typically don't have to do an air heater wash outside of our normal, outage season.
Great. So the way the system was installed, it actually tracks essentially coal sulfur, but it tracks it as SO2 going into the scrubber, and it automatically adjusts the injection rate based on a slew of parameters and calculations kind of built into the PLC. So something that our customers are interested in is, hey, does the system actually automatically adjust and track for load, changes in load and changes in coal sulfur?
As far as automatic control, I don't know if we have to adjust much.
Well, the system takes care of that for you. So as the SO2 concentration, you have an SO2 monitor in your scrubber, and as that changes, it regulates the amount of reagent. And then similarly with load. So as you increase load, you increase the amount of reagent, decrease load.
Yeah, the lance maintenance is done by our in-house contractors that are here daily. It's set up on a 7-day PM, or if a unit comes offline, as soon as the unit's back online, we'll go through the lances and clean them. They got it down to a science. It's 2 guys for a 4-day, during the week. So, but it's probably one of the most critical things that we do on the system is maintaining the cleanliness of the lances, checking for gasket leaks. By pulling the lance, you can look at the shroud and see how they look, make sure there's no holes in the shroud. So, and then also, when they're reinstalling the lances, they'll be able to tell if there's any buildup around. Once we see flow deteriorating, we'll run a small dose of cleaning agent through it. The other thing we do as far as maintenance, anytime we are offline, we'll open the doors and just look inside the ductwork. Just the routine maintenance, you're probably looking at, for 2 guys, you're, doing that piece of work. It's, maybe $80,000, in labor cost, minimal, material cost on that. Yeah, the system really doesn't need a whole lot. Yearly maintenance is pretty minimal on the system. It's one of those things I forget about, honestly. Until,
that's not a bad thing.
That's not a bad thing.